Hello, science enthusiasts. I am Atom. Join me in this adventure where we explore the law of conservation of momentum and the physics behind collisions. The law of conservation of momentum. Think of it like sharing pencils. Imagine Ion and Isaac working together on a science problem. Ion has 2 pencils and Isaac forgot his in another classroom. So Ion lends him one. They are now a team or a system in physics lingo. Before the pencil swap, they had 2 pencils. Afterwards, they still have 2 pencils. As long as no one else gives or takes pencils, this system is a closed system. No pencils were lost or gained. The pencil was just transferred from Ion to Isaac. This is what we mean by conservation. The total number of pencils stayed the same. Is it the law of conservation of pencils? Now, let us apply this idea to momentum. Imagine this scenario. Ion, mass 50 kilograms, and Mole, mass 45 kilograms, are standing at rest on an ice skating rink, waving their hands and talking happily. Ion and Mole comprise a closed system. At this moment, their total momentum is 0 kg meter per second, since they're both at rest. But then, oops, they push each other accidentally and slide away from each other. The question is, who would have a higher momentum change? According to Newton's third law of motion, they both exert equal and opposite forces on each other. Also, these forces are being applied on each other for the same amount of time. Therefore, the impulses, remember that impulse equals force times time? The impulses acting on each other are equal and opposite as well. Since Ft equals delta mv, or impulse equals change in momentum, the change in momentum for both is equal and opposite. So Ion, who has a higher mass, would have a smaller velocity change, while Mole, who has a smaller mass, will have a higher velocity change. But both of them will have the exact same change in momentum, but in opposite directions. Since momentum is a vector quantity, their equal and opposite momentum cancel each other out. In other words, their total momentum after they push on each other equals 0 kilogram meter per second as well. This shows that momentum is conserved. It is like a magic roll. As long as nothing else interferes, the total momentum before and after the push stays the same. Now, on to collision physics. This is about what happens when things bump into each other or collide. There are 2 kinds of collisions. Elastic collisions are where objects bounce off from each other after collision with no lasting deformation. Both momentum and kinetic energy are conserved. In the real world, a perfect elastic collision is not possible due to friction losses. However, the motion of the balls on a pool table can be a close approximation of an elastic collision. Inelastic collisions are where objects are stuck together and they move together after collision. While momentum is conserved, kinetic energy is not conserved. Part of the kinetic energy is converted to heat energy and sound energy. A collision between 2 vehicles is an example of an inelastic collision. How about some challenge questions? 2 toy cars collide elastically. One of the toy cars is initially at rest and the other is moving. Can both the toy cars come to a rest after the collision? Pause here and check your answer. The answer is no, because if momentum was not 0 before, it cannot be 0 after the collision. Momentum is always conserved. A red toy car of mass 2 kg collides elastically with a velocity of 1 meter per second with an equal mass green toy car which is at rest. Calculate the final velocities of both toy cars. Pause here and check your answer. The total momentum before collision equals 2 kilograms multiplied by 1 meter per second, which equals 2 kilogram meter per second. Since momentum is conserved, the total momentum after collision is also equal to 2 kilograms meter per second. For this to be true, the red toy car needs to come to rest, and the green toy car needs to move at a velocity of 1 meter per second. Therefore, if the objects have equal masses in an elastic collision, they will just swap their velocities after collision. Isaac, of mass 39 kilograms, stands still on a frozen pond, clad in his ice skates. A 1 kilogram ball flies at him at 4 meters per second, which he catches, causing both him and the ball to slide on the ice. Disregarding friction, what is their combined velocity? Pause here and check your answer. This is an example of an inelastic collision. Momentum is conserved in this collision as well. Total momentum before collision equals 1 kilogram times 4 meters per second, which equals 4 kilogram meter per second. Therefore, the total momentum after collision is also equal to 4 kilogram meter per second. Total mass after collision equals 40 kilogram. Therefore, the final velocity of Isaac carrying the ball will be equal to the momentum divided by the total mass, which equals 4 kilogram meter per second divided by 40 kilogram, which equals 0.1 meter per second backward. Exo, of mass 50 kilogram, is ice skating at a certain velocity when she accidentally collides into Valence, of mass 40 kilograms, who is ice skating towards her at a velocity of 2 meters per second. Right after the collision, both abruptly come to a stop. What is Exo's velocity before the collision? Pause here and check your answer. Total momentum after the collision equals 0 kilogram meter per second, since they both came to a stop. Since momentum is conserved, total momentum before the collision is also equal to 0 kilogram meter per second. Total momentum before collision is the combined momentum of both Exo and Valence, which equals 50 kilogram times the velocity v plus 40 kilogram times negative 2 meter per second, since Valence was moving in the opposite direction. Since the total momentum before collision equals 0 kilogram meter per second, we can equate this equation to 0 kilogram meter per second. So we get 50 kilogram times v plus 40 kilogram times negative 2 meter per second equals 0 kilogram meter per second. When you do the math computation, you would calculate the velocity to be equal to 1.6 meter per second. So, Exo's velocity before collision equals 1.6 meter per second towards Valence. I hope you have mastered the law of conservation of momentum and the thrilling physics of collisions. Happy learning! Thank you.